In this video, we'll be talking about a type of questions in A-level chemistry practical, and that is the qualitative analysis questions involving identifying two cations in an unknown solution or solid. So let's get started. So let me summarize what we will be covering in this video. So firstly, we'll be looking at how do we know from the question that we are being asked to test for cations, okay, if they didn't write it explicitly that we are testing for cations. Next, once we know that the question is asking us to test for cations, we'll be looking at identifying whether there are two cations. Usually the question will tell you there are two cations if there are. And so we'll be looking at the QA questions, how they are being structured when we are being asked to test for two cations. Okay? So let's first start off with this. How do we know we are being asked to test for cations from the QA question? This is the QA or the qualitative analysis notes that you will see at the end of your question paper. So when you're taking your paper 4 or your practical chemistry paper, this will be provided and is found at the last few pages. So there is this page on qualitative analysis notes, and this is on the reactions of aqueous cations. So if you look at this, this allows you to test for cations, and based on this observation, you can deduce that these ions are present. So if you take a look, what are the reagents that are being added? It is basically aqueous sodium hydroxide solution or aqueous ammonia. So in short, right, if you see a question asking you to add aqueous sodium hydroxide, okay, dropwise and then in excess, or it asks you to add aqueous ammonia dropwise then in excess, it means that it is giving you a clue that you are testing for cations present. What are the cations present? Okay, so let's look at the two steps. So I say that when you are asked to add either sodium hydroxide or aqueous ammonia, it is a hint to you that they are asking, the practical question is asking you to test for cations. Okay, and when they ask you to add sodium hydroxide or aqueous ammonia, there are two things you need to take note of. First thing, okay, the first thing is initially you will add sodium hydroxide or aqueous ammonia dropwise. What is the purpose of adding them dropwise? Well, it is to see whether there is a precipitate, and if there is a precipitate, what color is it? All right. So you notice from all your QA notes, right? They'll give you, oh, is there a precipitate or not? Okay, and if there's a precipitate, they'll tell you what color it is. Like for example, it's white, gray, green, and so on. So first step, when you add sodium hydroxide or aqueous ammonia dropwise, basically what you're doing, you're testing for whether there is any precipitate. Okay, and if there is any precipitate, you need to record down the color. Okay, next, once the precipitate is formed, okay, you will add sodium hydroxide and aqueous ammonia in excess. And the purpose of adding it in excess is to see whether the precipitate will dissolve in excess aqueous ammonia or excess sodium hydroxide. So if it is soluble in excess, you will get a solution, a colored solution. All right. So what you need to do is to so if it's soluble in excess, what you need to tell or what you need to write in your chemistry practical exam is what color solution is formed. So you must say the precipitate is soluble in excess sodium hydroxide or aqueous ammonia, and what is the color of the solution form. Okay, if it is insoluble, you just say that it's insoluble in excess sodium hydroxide or aqueous ammonia. Okay, so based on the color of the precipitate color and whether it is soluble or not, you can actually determine the cation that is present. For instance, if you have a gray-green precipitate that is soluble in excess sodium hydroxide but insoluble in excess aqueous ammonia, then you know that chromium ions are present. But usually, right, for your QA exams, they'll only ask you to put one of the reagent, either sodium hydroxide or aqueous ammonia. But once you see the color of the precipitate and whether it is soluble in excess or not, you will be able to tell, you will be able to narrow down the type of cations that is present in the solution. All right, let's come back to this question. How do you know that you are testing for cations in your chemistry practical, which is paper 4 of A-level chemistry? Well, in short, it is when you see the question asking you to add aqueous sodium hydroxide and aqueous ammonia or aqueous ammonia, it is a clue that very likely you are testing for cations. So if you are testing for cations, two things to look out for. First thing, the precipitate. Is there any precipitate? And if there is a precipitate, what color it is? Second thing to look out for, once you see the precipitate, you need to add the reagent, that means sodium hydroxide or aqueous ammonia in excess, and see whether that precipitate dissolves in excess sodium hydroxide or excess aqueous ammonia or not. If it is soluble, then what you need to observe is what color is the solution form. Okay, so when you are describing the observation, you will be saying what color PPT form, okay, and whether the PPT is soluble in excess aqueous sodium hydroxide or excess aqueous ammonia. And if it is soluble, you need to add another sentence, which is what color is the solution form when it dissolves. All right, so now that we have covered how we know that we are being asked to test for cations in your chemistry practical, next let's look at this particular type of QA questions where you are asked to identify two unknown cations in the solution. Okay, next, let's use a QA question that involves testing of two cations to illustrate how this type of questions are being structured and how you, as the student, are supposed to answer this type of questions. All right, so let's take a look at this question which I have adapted from ASRJC 2020 prelim paper 4. Okay, so if you want to see the full question, do refer to this paper. So in this paper, right, in this question on QA, you are given FA8, which is a solution containing two cations with different oxidation state. So there are two clues here, two cations and different oxidation state. So now let's look at the test, what you are supposed to do. So you notice that in the first part, you are supposed to add aqueous sodium hydroxide until no further change is seen. So in other words, you are supposed to add dropwise to look out for the precipitate, then add excess until you see no change. So in other words, you need to see whether the precipitate, so until no further change is seen, this step is to check whether the precipitate is soluble in excess sodium hydroxide or not. Okay, then after that, you are supposed to filter the mixture and add dilute sulfuric acid. Okay, so when you filter the mixture, right, what you are doing is you are going to get the solution containing the cation that has dissolved in excess sodium hydroxide. Okay, and you're going to add acid. And what does the acid do? The acid basically reacts with the excess sodium hydroxide. So it removes sodium hydroxide. So you will be able to see the precipitate that has dissolved in excess sodium hydroxide. All right. Okay, so now let's take a look at your qualitative analysis notes on the portion on testing for cations. All right, so in the question we are told that, right, there are two cations with different oxidation state. So let's take a look back at the qualitative analysis notes for aqueous cations. If you take a look at this table, right, you'll notice that almost all the cations have a charge of +2 and +3, right? The only exception is ammonium. Okay, so ammonium, this cation has a charge of +1, and there's something that is slightly different for ammonium. So instead of looking for precipitate and seeing whether it's soluble in excess or not, in order to test for ammonium, you have to heat the solution. Okay, when you add, okay, you need to add sodium hydroxide and then heat it, okay, for ammonia to be produced. So if you take a look at the question, there is no parts of it asking you to heat the solution. Okay, so if you add sodium hydroxide but they did not ask you to heat, very likely, right, you are not testing for ammonia, because in order to test for ammonia you need to heat it, and if ammonia gas is produced, then you can conclude that it is ammonium ion. But if there is no, if you do not heat it, that means you're not testing for ammonium. Okay, so from this question, right, so later on I'll go through the question again. So there is no part of that question asking us to heat, so very likely we are not testing for ammonium. Okay, so if we eliminate ammonium and we look at the other ions present in the cations table, right, you notice that they only have a charge of +2 and +3. So in short, right, it tells us that since the two cations have different oxidation state, that means one of it has a charge of +2 and the other one has a charge of +3. Now let's come back to the question. So let's look at the test and what are the observations that you would see. So in the first test here, where you add sodium hydroxide until no further change is seen, in other words, you are adding sodium hydroxide dropwise to check for precipitate. Then until no further change is seen, you're going to add more sodium hydroxide to check whether the precipitate is soluble in excess or not. And this is what you observe. Okay, you observe that there's a pale blue PPT form insoluble in excess NaOH. Okay, then next you are going to filter the mixture, add dilute sulfuric acid to the filtrate. And here is what you observe. Colorless filtrate obtained. Okay, white PPT reappears when dilute H2SO4 is added and the PPT is soluble in excess H2SO4 to give a colorless solution. Now, let's refer back to the qualitative analysis notes for the testing of aqueous cations to understand these observations. All right, let's come to this test. Let me explain the observations. So this, in this, right, so I have Fa8. I know that I have Fa8 and there are two cations. So I'm going to add sodium hydroxide until no further change are seen. So for this type of testing for two cations type of QA questions, right, when you add aqueous sodium hydroxide, okay, what happens is you will see precipitate, okay, form from two of the cations. All right, so that precipitate from two cations. Okay, and why do you need to filter the mixture? Well, this is because, right, of the two precipitates formed, right, one is soluble in excess sodium hydroxide and the other one is insoluble in excess sodium hydroxide. Okay, so one is soluble in excess NaOH and it will be inside the filtrate. Okay, while the other one is insoluble in excess NaOH, and that would be found in the residue when you do the filtration. So in other words, right, when you do the filtration, okay, what you get inside your conical flask will be the one that is soluble in excess NaOH, and the one here is insoluble in excess NaOH. Okay. And based on this observation here, right, we know that the one that is insoluble in excess NaOH is blue PPT. Okay, so let's go back to this table here, your QA qualitative analysis notes for cations. You notice which one gives a blue PPT that is insoluble in excess NaOH. Well, that is copper ions. So we know that this cation here, or this precipitate here, is formed due to Cu2+. So we have already identified one of the unknown cation, which is Cu2+. All right. So I know that there is Cu2+ here. Okay. So now I have identified Cu2+. Okay. So, and Cu2+ is the one that forms a precipitate that is insoluble in excess NaOH. Next, I have another. So next, I'm going to filter, right? So the Cu2+ will be in the residue, and the one that is soluble in excess is in the solution here. And after you do the filtration, right, you'll notice that you have a colorless filtrate. Okay, so let's so first thing, you know that it's colorless, right? So once you know that it is a colorless solution, right, you can eliminate all the colored stuff. Okay. Okay, and also because it is a filtrate, it is soluble in excess NaOH. So based on this, right, look back at this table here, your QA table for cations. Look for the cation which is produce which will produce a white precipitate that is soluble in excess NaOH to give a colorless solution. So if I look at this table, I know that I have two possibilities. One of it is Al3 plus and the other one is Zn2 plus. Okay, so now I know that I have either Al3 plus or Zn2 plus. Okay, and unless I add NH3 aqueous, okay, to test, I will not be able to tell whether it's Zn2 plus or Al3 plus. Okay, remember, for aluminium and zinc ions, they will produce a white PPT soluble in excess NaOH. So it's the same when you use NaOH. The only way to distinguish aluminium ions from zinc ions is to add aqueous ammonia. So aluminium ions when you add aqueous ammonia, it will form a white PPT insoluble in excess aqueous ammonia. But for zinc, right, it will form a white PPT soluble in excess aqueous ammonia. And that is how you distinguish Al3 plus from Zn2 plus. But if we do not do a test with aqueous NH3, then how do we determine whether it's Zn2 plus or Al3 plus? Well, apart from knowing that there are two cations, we also know that the two cations have different oxidation state. And we are already confirmed that one of the cation is CO2 plus. Okay, so in other words, right, the other cations will have a charge of plus 3, right? Because we also eliminated NH4 plus. Okay, so basically, since I know that the other cation will have a charge of plus 3, so therefore I am left with Al3 plus. So in other words, I can conclude that the other cation is Al3 plus. Okay. Okay, so the two unknown. So based on these two observations here, right, we can conclude that the unknown cation is CO2 plus as well as Al3 plus. Okay, now next, what I want to do is I want to explain why we add dilute sulfuric acid. So why is it that when we add dilute sulfuric acid, we will first see a white PPT, okay, and then it dissolves in excess sulfuric acid. So recall initially, right? Okay, so if I have aluminum ions present and I were to add sodium hydroxide, what will I get? I'll get a white PPT, right? And when I add excess NaOH, right, this PPT will be soluble in excess. So it becomes the colorless solution which we had filtered out and it is in the filtrate. So now by adding sulfuric acid, what am I doing? I am basically removing sodium hydroxide. So when I remove the excess sodium hydroxide, okay, your white PPT is no longer soluble in excess sodium hydroxide because there's no more sodium hydroxide, right? So it will precipitate out. It will reprecipitate out. Okay. Okay, so it will reprecipitate out as iron hydroxide. Okay. Then I add excess sulfuric acid. So sulfuric acid plus excess aluminum hydroxide. What do I get? Well, I get aluminum sulfate. And aluminum sulfate, as we know, is soluble in water. That is why it dissolves to give a colorless solution. Alright, for those of you who like to see things in chemical reactions, so let me explain it in terms of chemical reactions, alright? So firstly, right, we know that there are two cations. So basically, from just now, we know that the two cations present are CO2 plus and Al3 plus. So let me explain what is actually happening. So initially, when you add sodium hydroxide, okay, what is happening is CO2 plus and Al3 plus, they will form a precipitate, hydroxide precipitate. Okay, recall that both CuOH2 as well as AlOH3, they have a very low Ksp, so they precipitate out very readily. Okay. Okay, and this is the blue precipitate that we see. This is the blue PPT, or blue precipitate, and this is a white precipitate. Okay, then you'll be wondering, hey, why is it that I only write a pale blue PPT is formed. I never write blue and white PPT form. Well, this is because, right, when you have a blue PPT as well as a white PPT, right, the blue color is more intense than the white color. You won't be able to see the white PPT. Okay, so that is why we only say blue PPT form. Okay, and this blue PPT is insoluble in excess NaOH, so you actually still see after adding excess NaOH. So next, we know that we have this 2 PPT when we add NaOH. Then next, when we add excess NaOH, what happens is aluminum ions forms a complex, okay, AlOH4 minus, okay. And this is a relatively stable complex, and this complex is soluble in water. So what happens is this aluminium, the formation of this complex will reduce the concentration of Al3 plus in the solution. Okay, so when the concentration of Al3 plus decreases by Le Chatelier's principle, right, more AlOH3 will dissolve. So this causes your AlOH3 to completely dissolve in excess NaOH. Okay. So once it dissolves, it becomes the colorless solution. Okay, so this colorless solution is found in the filtrate. Okay, and this is soluble. Okay, so therefore, right, when we add excess NaOH, all the AlOH3 will have dissolved because they have been converted to AlOH4 minus. Okay, but copper 2 hydroxide remains in the solution as a precipitate, so it did not dissolve. So this is the PPT that we see, and this is the colorless solution that is present after adding excess NaOH. So when we were to do a filtration, the residue is this blue PPT, CuOH2. And the filtrate is this colorless solution containing aluminum ions. Now, when we add H2SO4, what we are doing is we are getting rid of this. Okay, we are getting rid of OH minus. So when you have very little OH minus left, what happens? You will not have this complex, right? So you will reprecipitate out AlOH3. Okay, so you will get a white PPT. So white PPT reappears, and this white PPT is basically your AlOH3. Okay, so next, this white PPT will dissolve when we add excess H2SO4. Why? So if you look at this, aluminum hydroxide, it is a base, right? And H2SO4 is an acid. What happens when you add an acid to a base? Well, you form a salt and water, right? Okay, and what can you say about the solubility of aluminum sulfate? Well, all sulfates are soluble except for barium sulfate, and calcium sulfate is partially soluble in water. So based on this, I know that aluminum sulfate is soluble, so therefore it is aqueous, and therefore this is the colorless solution that we have. The colorless solution that we have when we add excess H2SO4 is basically a solution containing aluminum sulfate. Okay. All right, let me summarize the process when we are testing for two cations. Okay, so when there are two cations, right, and we want to test for them, okay, we will either add NaOH or aqueous NH3 in excess. And what happens is this cation, one of it is soluble in excess, NaOH or NH3, and the other one is insoluble in excess, okay, whether it's ammonia or NaOH. So you have one of it is soluble, one is soluble in excess, and the other the other cation forms a PPT that is insoluble in excess. Okay. Okay. Once we have formed the PPT and one of it has dissolved in excess, what we need to do next is to do a filtration. Okay. And the one that's insoluble in excess will be found in the as the residue. Okay. And so you look up in your cations table to determine what ion it is based on the color of the precipitate form, okay, and whether it is insoluble in NH3 or NaOH. Next, there is another cation that is soluble in excess. Okay, so next we can determine what cation this is by looking back at your QA cations table to determine the cation based on the color of the solution. Okay, so if you have a colorless solution, uh, when if the PBT is soluble in excess, for example, NaOH, to give a colorless solution based on the QA table, we know that it is either aluminum ions or zinc ions. Okay, so based on this, you can look back at the QA table. Okay, then very often the question will ask you to add acid to the filtrate. Okay, so they will ask you to add acid to the filtrate. So what you are doing when you're adding acid to the filtrate, right, is to remove the NaOH. And if you see a PPT, it is trying to show you that, hey, there was actually a cation, there was actually a precipitate formed from this cation as well. And it is soluble in excess. Okay, but because you have two cations and one wasn't soluble in excess, you can't really see that some of this cation was formed. Okay, so basically, when you add acid, to the filtrate, what you are doing is to remove the excess OH minus or NH3 that is used to form the complex that cause the cation to dissolve. Okay, and it is to show you that initially there was this PPT. Okay, so when you add excess of the acid, right, what you are doing is it is basically an acid-base reaction. So if the salt form is soluble in water, then it will dissolve in excess acid. If the salt form is not soluble in water, then it will not dissolve in excess acid. All right. So I hope you get the grips of you understand this concept of testing for two cations, because it's quite a common type of test that you will see in the paper for qualitative analysis. Thank you for watching this video. I hope it will help you in your paper 4 practical exam for chemistry. So if you like this video, do subscribe to our channel and like our video. Thank you and see you.